Okay, we are going to go ahead and dive into laws of exponents. You need to understand the laws like the back of your hand, or you'll be left behind. All right, laws of exponents. Let's go ahead and just dive in to some examples, to some problems, and make sure you understand these laws. So say you have 5x squared times negative 7x to the 6th power. Well, this is the times symbol here. You're multiplying 5 times negative 7. So I'll show you on the side what you're doing here. So you're multiplying here, your big numbers, right? Your coefficients. And then you take your x squared times x to the 6th power. This is called your product rule. If you are multiplying two terms with the same base, this is a term, this is a term. They've got the same base, x, right? If you're multiplying two terms with the same base, the law says you can add their exponents. 2 plus 6. So your final answer is 35, negative 35 times x to the 8th power. And you circle your answer. So you don't have to show all this work, but that's the work that should be done in your head or somewhere on the slide in some form. The reason why it's x to the 8th power is because we've got x squared means x times x, and x to the 6th power means x times x times x times x times x times x. So some number times some number multiplied by some number times some number, that same number, right? So you're multiplying the same number to itself 8 times. You count those up, you get 8 x's, right? That's the theory behind it. So this is called the product rule. Make sure you write your rules down. There's like 5 or 6 of them. Same base, you can add the exponents. If you're multiplying the same base, you can add the exponents. You add them. Okay? There you go. All right, next law. Say you have, for example, well, let's go ahead and actually do this one. Let's say we have m to the 4th power times negative 2m to the negative 7 power. It's the same thing. You're going to underline your negative 2 there because that's a big number, coefficient. Just drop it low. And then you're going to go ahead and squiggle the m. So that's m4 plus negative 7. You add the exponents. So what does that give you? That gives you negative 2 times m negative 7 plus 4, or 4 plus negative 7, same thing, is negative 3. I want you to circle this m to the 3rd power, m to the negative 3rd power. We don't keep exponents negative. We instead write it like this. So 1 over m to the 3rd power, 1 over m cubed. Okay, so this is saying negative 2 times 1 over m cubed. So we don't write it like this, we write it like this. So let's go ahead and give our final answer. Really what you're doing is you're keeping the -2 how you see it, okay? And you're just putting the red m to the -3 power at the bottom as a positive exponent. That's how you write it, okay? So -2 times m to the -3rd power is the same thing as -2 over m to the 3rd power. So this is a mixture of rules. Well, we added, so this was a product rule. And then we did the negative exponent rule. So that's your next rule. If you have a negative exponent, we don't leave exponents negative. Mathematicians don't do that. Physicists, chemists, scientists do not leave exponents negative. No, 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 no. Yes, 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 yes. Positive at the bottom. So I'll go into that rule a little bit later, okay? Let's go ahead and jump into the quotient rule. Quotient rule. What if you have 18 divided by 3, x to the, let's use a different letter, p to the 4th, p to the p, let's just say p, q to the 8th, and then q to the 3rd power. So what does this mean? 18 divided by 3 is 6, right? P to the 4th divided by p. What does that mean? That means you're taking 4 p's and multiplying it to itself, divided by 1p. So division, what does division mean? Division means one cookie for one person. Another cookie for another person. It's dividing cookies out. So say you have 4 cookies and you got 3 people, right? That means 4 cookies, 3 people. How do you divide that out? Well, one person gets one, another person gets a cookie, and you got 1 left over, and they would split it, right? So let's go ahead and take that concept with math. Well, that is math, but with these laws here, with variables, I should say. All right. So this means 4 cookies for one person. So how many cookies is left? You can only distribute to one person. Well, there's 3 left, so your answer will be p to the 3rd power. P to the 4th power divided by p is p to the 3rd power. There's 1 right here. There's an invisible 1 exponent that you can't see that you could write if you want to. Okay, so we've got 8 divided by 3 is 6. P over p to the 4th power divided by p is p to the 3rd power. And then we've got q we've got 8 q's, 3, 4, 5, 6, 7, 8. Divided by how many? 3. 1, 2, 3. So 1 cookie for one person, 1 cookie for one person. How many do you have left over? 5. And there's your answer. You're just dividing the cookies out. That's all you're doing. Now, I'll give you more theory behind this because you need to know how to do both. So make sure you take some notes. So here's more of the mathematical, well, that is a theory. That's a lie. But here's another way you could show your work or understand it. So the quotient rule, let me explain it, is if you are dividing the same base, you can subtract the exponents. So 4 minus this invisible 1 there, right? That's p to the third power. That is the quotient rule. Write that down. If you divide two terms with the same base, you can just subtract the exponents. Okay? So write that down. That's your quotient rule. Okay? So you divide 18 by 3 like normal. That's 6. You're dividing p to the fourth power divided by p, so you can just subtract the exponents. This is how you show your work. You're also dividing q to the eighth power divided by q cubed, q cubed. So you're subtracting the exponents. So that's how you get 6p to the third power times q to the fifth power. This is your work, okay? This was showing you the concept of it, of y, okay? You get 3 left over, okay? That's the visual. Let's go ahead and take it up a notch to negative exponents. Get this to your notes. Pause your video if you have to. So what if you have, for example, 5 divided by 25. We've got r to the second power divided by r to the fifth power times s to the seventh power and s to the third power. I'm just making up a question. All right, so just say, for example, you had this question and you had to simplify. So what you're doing is you're simplifying these exponential expressions. That's what you're doing. You're simplifying these exponential expressions. Well, let's take 5 divided by 25. 5 eggs out of 25 eggs, you ate 1/5, right? Then we've got r, so you're simplifying that, the big numbers, the coefficients. Now we've got 2 up top, so we've got 2 r's divided by 5 r's. So one cookie for one person. We've got 3 cookies, 3 people left at the bottom. So you put that there are 3 r's left at the bottom. If you have 7 s's up top, 2, 3, 4, 5, 6, 7, divided by 3, right? Then we've got 4 cookies left over, and that stays up top. And you would simplify your answer, s to the fourth power divided by 5r cubed. You don't need this 1 there if you have an s to the fourth power there. Now that's the visual way, right? That's like the easiest way. And I'll show you a little bit more tricks here in a second. Now, that's the one way. That's not really the best way. I want you to show it mathematically. Here's kind of a better, well, here's another way. Here's another way, okay? So 5 divided by 25, show your work there. That's 1/5, right? And then you take your r, your quotient rule says if you divide 2 r's like that, right, you can just subtract the exponents. And then take this s, you're timesing it by that, timesing it by this s, 7 minus 3. So you can do it this way. This is like another way to do it. 2 minus 5 is what? -3. And 7 minus 3 is a +4. So this is the answer. I mean, it works, but it's not simplified. So let's keep going. I just said in our other rule, you cannot keep exponents negative. I mean, you can, but you look cray-cray because that's not how we do it, okay? So I said you write it as a fraction. 1 over r to the third power and times s to the fourth power. This is like the mathematical way of doing it. Okay, now let's put this all together, make it like cute, you know what I'm saying? So the 1 stays up top, 1 stays up top. 1 times that 1, right? We got a 5 down here. Keep that down there. R3 down there. R to the third power. S to the fourth is at the top as well. And then make it look cute. Don't put those ones, 1 times 1, that's silly. Just put s to the 4th power divided by 5r cubed. Now, I don't show this way all the time. After this, no. This is like the more like steps, right? So you can see the theory or whatever, okay? So that's what you do. So this one was 2 minus 5. So it's a negative exponent, right? That's why it's at the bottom. And this was 7 minus 4, or 7 minus 3, which was 4, which is why it's at the top, right? You don't need all this stuff, okay? But that's like the theory, I guess, like the steps. No, don't. If you have to do it this way, cool. But I'm just showing you one time. Let me show you how you really do it, you know what I'm saying? That's how you do it quickly in your head on a test. Just quickly showing work, like do it like this for real, okay? So you're asking yourself, is it top heavy or bottom heavy? That's your question, okay? And then what's the difference? Or by how much? That is what you're asking yourself to make this easier. 5 divided by 25. Is 5 heavier or is 25 heavier? 25 is heavier. And you're dividing it, right? So it's, it's a 5 involved, 5 divided by 25. So keep the 1 up top, 5 at the bottom. R, is it top heavy for R or is it bottom heavy for R? There's more R's at the bottom. By how much? By 3. There's 2 at the top. And there's 5 at the bottom, right? So there's more at the bottom by 3, right? So, by 3. So you put that. For the S's, are there more up top or more at bottom? It's top heavy for S, right? By how much? 7. The difference of 7 and 3 is 4. So, and then that one, not cute. Just simplify it, okay? So that's really the best way to do that one, okay? But I just showed you guys like the steps, which you need to get that in your notebook. That way you understand the concept of it. So that's an example. Let's do another one just like this. Get this in your notes. So let's do negative 3 out of 18 times m, and we're dividing it by m to the 4th power, ends up here to the 8th power, and ends down here to the 5th power. All right, so you're just dividing 3 out of 18, right? It is bottom heavy, so your number will be at the bottom. 3 out of 18 is 1 out of 6. That's what it is, okay? Now the question is it top heavy for M or bottom heavy? You got it. It's bottom heavy. There's more M's at the bottom. By how much? There's 1 up here. There's 4 down here. What's the difference? 3. You got it? Okay, top heavy or bottom heavy? Top heavy. By how much? What's the difference? 3. 8 minus 5 is 3. Again, you don't need that. 1 n cubed. You don't need to say that. Just say n cubed. Okay? And there's your final answer. This can be done very quickly in your head just by asking, is it top heavy or is it bottom heavy? Right? By how much? That's the question. You're taking 1 minus 4, which is negative 3, which is why it's at the bottom. 8 minus 5 is 3. Keep it just right there, up top. Okay, let me give you another one to try on your own. Your turn. All right, go ahead and pause the video and try it. Okay, you should have got 14 divided by 7. It's top heavy, right? So 2, right? And then are we top heavy or bottom heavy for W? Top heavy, so that goes on the top. By how much? 12 versus 3. That's a difference of 9, right? And then X, is it top heavy or bottom heavy? Bottom heavy. By how much? 2. 5 minus 3 is 2. And there's your answer. 2 times W to the 9th power divided by X squared. So that is the quotient rule, and it is mixing it with the negative exponent rule. Next, negative exponent rule, because you're saying 3 minus 5. So you could also write it like this. But this, nah, bruh. Nah, no. But know that you can write it that way. You need to understand that. That's why you need to simplify it. Give me your final answer. And we're putting this at the bottom. This right here is the negative exponent rule, where it needs to go at the bottom. Okay? That's why there's 2 rules mixed together here. Get this in your notes. Get this in your notes. That this is cute. It's the correct answer, but it ain't simplified. Okay. So we're going to go ahead and move on to our next rule. Which is, well, we're going to go ahead and explore our negative exponent rule. All right, so let's go ahead and explore the negative exponent rule. So say you have x to the negative 3rd power. Not cute. Scientists don't do that. We don't keep exponents negative. This means decay. It means going backwards in time. It's just a time machine. Like, it's fine. It's just we don't write it like that. So let's show the time machine more properly, okay? So it's a fraction. X to the negative 3rd power means 1 over x to the 3rd power. That's what it means. So think about it. If you are decaying, okay, this is growth. Write this down. This is decay. So where do decaying things go on the earth? If you're a decaying plant or decaying animal, where do decaying things go on the earth? You got it underground. So let's say 10 to the 3rd power is the growth. What is 10 to the 3rd power? That's 10 times 10 times 10 times 10, right? 1,000. What is 10 to the negative 3rd power? Are you growing? No. Reverse. Cha-cha. You're decaying, bruh. Like, so it's not negative 10. No, it's a good idea. But you're saying that you're taking this 10 to the negative 3rd power under the ground. You're doing the same thing, just under the fraction bar. So your answer is 1 over 1,000, or 1,000th. So this is a fraction. And this is some kind of whole number or non-fraction. Might not be a whole number, but it's going to be, it's not a whole number. It's a non-fraction. So that's why anything to the negative power is a fraction, okay? That's the concept behind it. Get that in your notes. So 5 to the negative 3rd power. Go ahead and write 5 to the 3rd power for me. What does that equal? And what does this one equal? Pause your video. Go. Okay, 5 to the 3rd power means 5 times 5 times 5, which is 125. It is a whole number or a non-fraction number. It's above the ground. Okay, it's over 1, right? It's greater than or equal to the number 1. It's not less than 1. It's not a fraction. This means dying. I'm dead. So 1 over the same thing. So 1 over 125. Okay. Below is below the number 1. It's a fraction. Fraction. Okay. So that's the negative exponent rule. Let's take it a little bit up a notch. So y'all hate letters. I don't know why. It's just an unknown. It means an unknown to the negative 5th power. It's all that means, you guys. An unknown will look like that unknown 5 freaking times, right? That's all that means. It's an unknown times itself 5 freaking times. Or you could say the unknown to the 5th power, right? That's how you write that. M to the negative 5th power is the same thing as 1 over m to the negative. M to the negative 5th power is the same thing as saying 1 over m to the 5th power. Go ahead and try this one. Go. Your turn. Okay, you should have showed some work. That means you're taking some number times itself 7 times. 3, 4, 5, 6, 7. So, or you can say into the 7th power, right? There you go. You know, but this is the same thing. This is correct, but you ain't no scientist if you're writing it that way. This is correct, period, okay? So let's call this a negative exponent rule. Write that down, negative exponent rule. Now let's take it up a notch. If you have x, if you have some number, let's say you have 5 to the negative 1 power. What does that mean? Okay. Well, like I said, it means that you're flipping it. This means 1 over 5. You're flipping it. So you can also say 5 is the same thing as saying 5 over 1, right? Just flip it. 1 over 5. 5 to the negative 1 power means what is the inverse of negative of 5? What is the inverse of 5? Well, the inverse of 5 is 1/5. It's the opposite. Flip. It's the flip. Okay. So let's try another one. I'm gonna give you another one. Okay. Clear page. This thing is. Okay. What is the inverse of 1/4? AKA, this is how you write it. What is the inverse of that? Okay, you got it. It's 4. Flip it. 4 over 1 or 4. Same thing. The inverse of 1/4 is 4 over 1 or just 4. The inverse of 4 or 4 over 1, right, is 1 over 4. Flip, reverse, reverse. So let's go ahead and try letters. Your favorite, right? What is the inverse of x? Pause your video. You got it. It was 1 over x, right? Instead of x or x over 1, same thing, you flip it. So 1 over x. The inverse, that means inverse of x is 1 over x. All right. Well, cool. What is the inverse of 1 over x? Your turn. Go. You got it. It was x, or x over 1, but just x, right? Okay? Okay. X over 1 is the same thing as saying x. Do you go around saying, I got 5 over $1? No, you say I got $5. Okay, let's go ahead and bring some more letters into it. Excuse me, princess. All right, so say you have w to the 5th power divided by w, and you take the inverse. Try it without my help. Pause the video. Okay, well, this tells you can flip this mug. Flip it. Yeah, princess, you say it, girl. Flip it. W over w to the 5th power. But you have to simplify, right? So w over w to the 5th power is w1, there's a 1 here, minus that 5. So that's w to the negative 4th power. But guess what? You gotta flip it again. Because we don't keep exponents negative. Nah, bro. We put it at the bottom. It's decaying. And there's your answer. I'm going to show you another way to do this problem as well. But that's one way. This is your flipper. It's taking the inverse. So you can say in a silly way, I'm flipping it. Right? Flipping. All right. So the inverse of w to the 5th power divided by w is 1 over w to the 4th power. Let me show you a different way to do it. You ready? Erase all this crap. Okay, so another way is to handle what's inside your house first. And I'll be honest with you, you probably want to do it this way instead. And you'll see why later. It can get complicated. So just handle what's inside the parentheses first. That's 5 minus 1, right? So there you go. Now you can bring down your flipper, right? Call it flipper for fun. Bring down the negative 1. Now flip it. Now flip it. What is the inverse of w to the 4th power? 1 over w to the 4th power, right? Put it as a fraction, and there you go. This, I think, is the better way to do it. Handle what's inside your house first, and then flip it, and reverse it, then flip it, okay? Let's try another one. Get this in your notes. Pause the video. Okay, your turn. What if you have 2x to the 3rd power divided by 12x to the 8th power, okay? And we're taking the inverse of it. Try without my help first, okay? All right, so I just said it's best to do what? Handle what's in your house first, your home, your parentheses. So 2 divided by 12 is 1 over 6, right? 1/6. 3 minus 8. Well, remember, is it top heavy or bottom heavy? It's bottom heavy. By how much? 8 minus 3 by 5, right? Cool. Bring this down. It does not disappear. Now what do? Flip it. You got it. This is your flipper. So 6x to the 5th power. So put this up top, right? This thing acts so weird sometimes. Okay. All right. There we go. All right, so we're going to flip it. Put the bottom up top, this right here, right? And put the top at the bottom. There you go. The inverse of 2x cubed divided by 12 times x to the 8th power is 6 times x to the 5th power. Remember, you don't need this 1. We don't go around saying, hey, y'all, I bought 6 eggs divided by 1. That doesn't make any sense. Just say I bought 6 eggs, right? Okay. get this in your notes. This is huge. There are two rules going on. First, it is your quotient rule. Write that down, right? Where you divide it, which also means subtracting your small numbers there, your exponents. And then we took the inverse. We flipped it. Or we call it negative exponent rule. Make sure you know both terminologies. Get this in your notes. There was two rules going on here. Sometimes you might have 2 or 3 rules or 4. Okay. So that is your quotient rule and your negative exponent rule all combined with this problem here. Now let's go to our power rule, okay? Power rule. Okay, so your power rule, so let's just say we have negative 2a to the third power times b. We take all that and we cube it, okay? And we times it by 8ab to the 9th power. I'm just making up a problem. So what this means here, let me explain the theory behind it. Negative 2 to the third power is negative 8, okay? And then a cubed to the third power is a to the 9th power. B to the third power is just b to the third power. Now you're wondering, how, Miss S? Where'd you get that from? I will show you the work here on the side here in a minute. Then you drop this, drop it low, drop this low. Now we're just timesing everything together. Everything's on the same level. There's no more 3 out here like that, throwing everything off and all these parentheses and all that stuff. So now we're all eye level. So negative 8 times 8 . 8 to the 9th power times a is a to the 10th power. You're adding the exponents because that's the product rule. And then b to the third times b to the 9th is b to the 12th. You're adding it. So this is your answer. Okay, that's how you should be doing it on your paper. But here's the theory. You're taking this negative 2 and you're taking it to the third power. So this third power is outside of the parentheses, so every term gets this power. So we can look at it as, there's a term, negative 2, and that gets the power. We'll make the power yellow. Like a light bulb, yellow. Let's take green. A cubed gets the power. Okay, and let's take pink. This blue or B, excuse me. This B also gets the power. So what does this mean? Negative 2 to the third power means negative 2 times negative 2 times negative 2. So that's negative 2 times negative 2 is 4 times negative 2 is 8, negative 8. And it's negative because there are 3 negatives being multiplied, which will end up being a negative. If there were 4, it will be a positive number. So odd numbers will be, if there's an odd number amount of negatives, it'll be negative. If there are an even amount of negatives, it'll be a positive, right? So this 8 is right here, right? Okay, now this green, a to the third 3 times means a to the third times a to the third times a to the third. It's 3 times. That's what this means. You're multiplying this to itself 3 times. What does a to the third power mean? It means a times a times a. This also means a times a times a. This also means a times a times a, right? How many a's is that? 3, 3, 3. Not 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where we get 9. So this is called the power rule because you're taking these two powers and you're multiplying them when they're like next to each other like that. 3 times 3. Okay? All right. Now this b just means you're taking b 3 times. There's a 1 here if you want to put it. So you're taking b to the first power, 3 times, right? Well, that's 3 of them. 3. Okay. And then you just drop it low, and you multiply this times this, which gives you this, right? And then you take your a's. There's 9. You're multiplying it by another 1 as well. So you're multiplying 10 altogether. 9 plus 1. And you're taking your 3 plus your 9. Because 3 b's be multiplied by 9 b's. So that's 12 b's total. So this is the theory. But you don't have to do all that. That should be done in your head. Or like on the side somewhere. But like you could do this. Show this work. But you shouldn't have to be doing that, right? Or just jump to it like this. You should know to take this to the third power, which is -8. You're taking this 3 times 3, which is 9, and then b to the third power. So that's kind of how you do that. Now your turn, okay? What if you have negative 3 times m times n to the 4th power raised to the, let's say, 3rd power raised to the 4th power times 2m times n. We'll say this. Negative 3m times n cubed to the 4th power times 2m to the 5th power times n. Go ahead and try without my help. I'll pause the video. All right, so you should have showed that you're taking negative 3 4 times. On this side, you can show your work if you need to, right? That's 9, that's 81. Negative 4 times is a positive. Okay. M to the 4th power is m to the 4th power, right? N cubed to the 4th power is n to the 12th. Make sure you make notes of this, that if you've got two exponents like this next to each other, n to the 3rd power to the 4th power, it means you're multiplying the powers. You need to understand that. So, n to the 12th power times 2. M to the 5th times n. Just drop it low. Now underline your like terms. 81 times 2 is a time symbol. All the stuff is being times. There's these invisible. There's these invisible, oh my gosh, I can't speak. There's these invisible timesings that you can't see, but they're there, okay? There's no plus sign, so the default is timesing. All right, 81 times 2 is 162. Is that true? I think so. Is it? Yeah. Okay, let's take our ems. 5 plus 4 is 9. And then you take your ands. There's 12 and there's 1, right? So that's 13. And there's your answer. Did you get this correct? Let me know in the comments, or let me know in person. So negative 3 times n cubed to the 4th power times 2 m to the 5th power times n simplifies to 162 times m to the 9th times n to the 13th. By the way, when I'm in class, I do not say all that. That is a tongue twister. I will lose my freaking voice. When I'm giving answers or saying it quickly, we're just like 162 m9 n 13. Like, make it easy. Okay. But okay, so that's that. That's called your power rule, honey. And it's mixed with your product rule as well. So this one there was double going on. This was your power rule. This right here is your power rule, where you multiply the powers, okay? Princess, move. You're on my laptop. And then we did the product rule once we finished our power rule. Now, okay, let's bring it on home by adding up the 4 and the 5 and adding up 12 and the 1, because they're all on the same level like that. So that's the product rule. So there was 2 rules going on here. Make sure you make note of that. So this was power. Let me erase all this red stuff. That looks crazy. Okay. This was your power rule. And this was your product rule. Princess, stop. I'm trying to make a math video, girl. All right. So that's the power rule. Right here, right? Mixed with a little bit of product. Just, just because. So I can show you when there's 2 rules involved. And our last rule, there's other rules. There's like this fraction rule, but we're not going over that today. Okay. Easiest rule ever. This one's called the 0 power rule. So any number to the 0 power is 1. Okay? X to the 0 power is 1. 1,000,000 to the 0 power is what? You got it. 1. C to the 10th power divided by C to the 9th power all over 1,000,005, 4, 3, 2, 1, whatever. All to the 0 power is what? 1. Okay? You need to know that. So this is, write that down. Pause your video. So, iPad. Okay. So this also applies if you have m to the 5th divided by m to the 5th, right? This crosses out and equals 1. You can also do it this way. This quotient rule tells you that you do what? Subtract your exponents, which gives you what? 0, which gives you what? 1. Either way. If you have 5 out of $5, that's a ratio of what? 1, right? They cross out. That's why it ends up just being 1, or it just crosses out. It disappears. So I'll give you an example like that. Write that down. So, for example, oh my God. I don't know if I like notability. I think I like good notes better. Say you have, let's say 4 times 5 times 5, 2 m to the 4th over m to the 4th times n to the 3rd divided by n to the 8th. How do you simplify that? Well, take the 4 divided by 2, which is 2. These cancel out. It's not 0, but it's just, there's a 1 there. 5 divided by 5 is 1. M to the 4 divided by n to the 4th is 1. And then this is bottom heavy, so there you go. Okay? You're asking what happened to these two. Well, you can also put times 1 if you want to. This, when you cancel it out, left you with 1, right? And then this, when you canceled it out, also left you with 1. that's why you don't write it. You just cancel it out because it's a 1. So 2 times 1 times 1 is just obviously 2, right? That's why you don't just cancel it out. Let me give you another example. Write this down. Pause your video. So what if we had 5 out of 5, x 4. So 5x divided by 5x divided by 5x to the 4th power. My mouth is getting tired, y'all, because all this 4th power, it's just a lot of talking. All right, so what do? Cancel it out. You're left with x to the 3rd power as a fraction, right? So this is a fraction because 1 minus 4 is this, which is that. Okay. So that's the zero exponent rule. Really, you'll get a question like this on a test. Answer's 1. Okay. Let's see if there's anything else I need to go over. Let me pull up the test because I can give you example questions that will be on your test. Okay, I'll give you an example. 15f to the 4th power times 2f times 4f to the negative 4th power to the 0 power. Okay, that's the question on your test. I'm just using different numbers. Well, let's look at it. Let's use our puzzle, our puzzle mind. What does this give you when you simplify that? 1. You got it? And then you take this 2f, multiply it, and take 15f to the 4th power. Same base. What can you do? Add the exponents. 4 plus this 1 here, right? So that's 5. And then you take your 15 times your 2, it's 30. So 30f to the 5th power. All you just did is 4 plus the 1 here. That's it. 5. 15 times 2 is 30. That's it. Times that 1, which you don't need that. Times 1, well, 30 times 1 is 30, right? That was a good question. So there was 2 rules going on there. Do you know what the 2 rules were? This was called the zero exponent rule. This is called what? Product rule. Get this in your notes. I'll give you 2 more examples, okay? This one's a good one. So say you have x to the 5th power times y to the negative 8th power to the negative 1 power. I'm giving you examples, not the actual test question. Well, there's 2 ways of doing this. Like I said, you handle what's in your house first before you handle this power. No, you can't do that because these are 2 different terms. You can't multiply x times y, and you can't add the exponents, so you can't do that. So that ain't gonna work. So your house is done. So now do the next step, which is your flipper. I call it your flipper, right? Take the inverse. What does that mean? 1 over. Just take this thing and put it at the bottom. From there, we don't leave exponents negative. We flip it. So flip it to the top. Y to the 8th over x to the 5th. I will show you another way to do this as well. This is also your power rule, so you can just times it. So that will give you x to the negative fifth power, right? And that will give you negative 1 times negative 8 is y to the positive eighth power, right? So negative and negative is positive. This is probably the better way of doing it. So who goes to the bottom? The y8 stays. This goes to the bottom. So either way, that's how you maneuver that kind of question, okay? I'll go ahead and give you one like that one. Get this in your notes. Here, your turn. Your turn. All right, you could have flipped it or make it easier and multiply. Bam and bam. So you should have gotten x to the fifth power, positive, right? Because this is positive 5 when you multiply. And then 7 times negative 1 gives you negative 7. Who goes to the bottom? Yep, he goes to the bottom. The 5, x5 stays, y7 at the bottom. Did you get that one right without my help? Okay, and last one. Okay. 4m divided by, 4 to the negative third power, m to the negative third power. That's confusing. N to the third squared, n to the negative 5. Okay, this looks crazy. I'm sorry, y'all. All right, this is a test question. So take it one step at a time, okay? These are the same base, 4 and 4. No, it's not. Ooh. It's a puzzle, by the way. Okay. Let's make this... No, sorry. Okay. Let's make these all m's, or it's not going to work. Okay, sorry. Redo. Okay, erase your paper, sorry. Okay, 4 times m to the negative third times m cubed to the second power divided by 4 to the negative third power m to the negative fifth power. So how do you do this? I'm looking at this like, what the heck? Start with one rule at a time. So like this one, see the 2 powers here? Well, you could do that one first, okay? So let's do one thing at a time. So 4 m to the negative third, then m to the 6th. To multiply that, 3 times 2 first, okay? And then rewrite everything and take a break. Now, this looks good right here. See, same base. We can subtract our exponents. So it's top heavy. So you know that your final answer will be up to the, you know that your m will be up top because it's top heavy. There's 6 at top. So m by how much? Well, the difference between 6 and negative 5 is 11, right? So you can also do it this way, 6 minus 5. It's just subtracting that negative 5. So m to the 11th power. So you're done with that. And then rewrite the rest. 4 times m to the negative third, 4 to the negative third. Okay, now you can take your product rule. This one's a hard one, you guys. 4 times this 1 here, right? Just keep your 4. And we have this rule called the product rule, where you can add the exponents. Negative 3 plus 11 is 8. Okay. From there, let's deal with this weirdo, right? 4 is the negative third power. What does that mean? Well, it means you're taking 4 to the third power, but you're flipping it. So what's 4 times 4 times 4? 16 times 4 is 64, right? Okay, so let's go ahead and say 4m to the 8th divided by 1 over 64. But that's still not good. Not yet. Four m to the 8th divided by 1 over 64. It's the same thing as saying 4m to the 8th times 64. It's the same thing. We don't divide by fractions. We don't divide by a fraction. Dividing by a fraction, no. We don't do that. You times it by the reciprocal, by the whole number. 4 times 64 is 24, 25. Ooh, that was a hard one, you guys. That was a very weird one. But that's on your test, by the way. So that's how you do those kind of power rules. I know it's a lot. But I should give you one like this. Okay? You go ahead and try it. That wore me out, I'm gonna be honest with you. Wore me the heck out. That was a weird question. Let me make sure I did that correctly. Let me double check my steps. Always double check your steps, y'all. This was the most obvious one to do this little power rule. That's how we got this here. And then you divide it by this. 6 minus negative 5 is 11. It's top heavy. So we got this right here. So we're done with this, right? So you drop this down. See, now you work with this here. Well, we see here, you could do this product rule, 4m. Add those together, you get 8. So here you are right here, and here you are right here. 4 to the negative third power is the same thing as putting it up here as 4 to the third power. So that's another way you could have done it. So let me show you. Just so you can see it. I like GoodNotes better, by the way, y'all. I don't know why. All right, so instead of doing this negative 3 like that, you could just rewrite it. Like this. Because we don't keep exponents negative. You flip it. You put it at the bottom or top, really. So if it's at the bottom, put it at the top as a positive exponent. I'm not sure if this was a test error or not. Maybe she meant to put an M here. But if not, that's weird. She might have meant to put an M. And if she did, then you would just add your exponents. Multiply 4 times 4 and that will be your answer. But the test does not have an m. It doesn't. So you cannot add your exponents because there's no m here. It has to be the same base to add your exponents, okay? So if this is how she meant to write the test, then these are two separate people. You can't do nothing with them. Just rewrite this one and then do the math on 4 to the third power, which is 64. And then take 64 times 4, which is at 256, and then keep the M8. So I showed you both ways just in case you made an error. I'd have to ask her later. Whew, my leg is falling asleep. All right, let's go ahead and try one on your own, right? Like that one. Make sure you got that in your notes. Rewind it if you need to get that. So your turn. One second, let me get this over more because I'm running out of room when I do these big problems. Okay, 4x to the negative. Okay, let me go to Good Notes. Good Notes does not do this to me. They're being super weird. Okay. So, say you have 4x to the negative third power times x to the fourth to the third power divided by 4 to the negative third power times x to the negative second power. Go ahead and try without my help, okay? Pause the video. Okay, you should have done this first. Do the easiest rule you see first, which is multiply 4 times 3, okay? Multiply. And then just rewrite everything down. From there, now you can easily see that these are the same x, right? So that means you're multiplying it x times an x, which means you add your numbers up here. I prefer Good Notes. It's way better. Oh my gosh. So that gives you 4. Keep that 4 up there. Negative 3 plus 12 is 9. And then just rewrite these at the bottom. What, princess? I'll play with you in a minute, okay? Okay, now we can do this rule, quotient rule. 9 subtract negative 2. 9 subtract negative 2. Right, that's 11. So let's just rewrite everything. Take this right here, it's top heavy, so there you go. And then let's bring this to the top because it's a negative exponent, so you're flipping it, taking the inverse. If it's at the bottom, to take the inverse, you put it to the top. That's the easiest way to do it, to be honest. So 4 times x to the 11th power divided by, times 4 to the third power. Now, hi, mommy. 4 to the third power, don't bite me, is 16 times 4. 64 times this. Then multiply your big numbers. Is it the same thing? 256 x to the 11th power. That's a hard problem. All right, so that is laws of exponents in full effect. I think I've gone over like every possible type of question. If I did not cover something, let me know and I'll make a separate video. But those are your laws. Make sure you just have your laws. I would say Make sure you have them listed down. Product rule, quotient rule, negative exponent rule, negative exponent rule, power rule, zero exponent rule. All right, so product rules, if you have the same base, you can add your exponent. So write that down. If you have a quotient rule, if you are dividing same base, you subtract your exponents. Negative exponent rule, if you have x to the third divided by x to the eighth, you subtract, same thing, and you invert it upside down. Okay? Or it's bottom heavy, that's why it's at the bottom. Same thing. Power rule, if you have 4xy to the fifth to the third, well, you're taking 4 to the third, x to the third, y fifth to the third, which gives you 64, x to the third, y to the 15th. So you can circle these multiply, 5 times 3, okay? But you're knowing that 4 to the third means 64, not 12. It's not 4 times 3. 4 to the third is 64. So make sure you understand that completely. And then zero exponent rule is anything to the 0 power is 1. Give yourself some examples here. X to the fourth divided by x to the fourth is 1 because you're taking 4, subtract 4, which is your quotient rule, right? Which is 0, which is 1. Anything to the 0 power is 1. So get these down. That way you understand your rules on like one part of your paper there all together. And put laws of exponents. So make sure you have that. On your paper I did give you guys a paper that had all your laws. Let's see if I can find it. Oh, that was not what I was looking for, but there's your rules there. They're also on your reference sheet, so you can write this down if you'd like.